Hey guys, this is our probably one of our last, not the last, but close to our last lesson here in this semester. Hopefully this won't take too long. It is properties of quadrilaterals. We're going to talk at the end about this, but these things are all kind of related to each other. And they all kind of like trickle down from the word quadrilateral, which really just means a shape with four sides, a polygon specifically, a polygon with four sides. So all the things we're going to talk about here are polygons with four sides. A parallelogram is a quadrilateral, meaning it's four-sided shape with two sets of parallel sides. Meaning like these two sides are parallel and these two sides are parallel. So two sets, two pairs. Say pairs is one if you want to. So given that, parallelograms have a bunch of properties. Like, for example, in every parallelogram, opposite sides are congruent. So like that side is congruent to that side, and this side is congruent to this side. Also in every parallelogram, opposite angles are congruent. So like this angle is congruent to, I'm not doing different colors because that's kind of hard to see what's happening there. Like this angle is the same as this one. And this angle is the same as that one. So those opposite angles are the same size. In a parallelogram, the diagonals bisect each other. Meaning whatever this length is, this one's the same. Whatever this length is, this one's the same. So it means to bisect. And consecutive angles, are supplementary. That's like because if these lines are parallel, then these two angles add up to 180. That's a property from parallel lines in micrometers. So every parallelogram has all of these characteristics. If you tell me a quadrilateral has two sets of parallel sides, then I know that all of these things about it are true. And you guys should write, as you're taking these notes, I want you to like write them neatly so that you can come back and look at these and see what the properties of these different shapes are, because we're going to need to know this later. So those are the rules for parallelograms. A rectangle is the next shape. This is a parallelogram. With four right angles. Or you can say a parallelogram with four congruent angles. Because if they're all 90, then they're all congruent. So it would just be like this, a bunch of boxes. Every rectangle has all the properties of a parallelogram. It is a parallelogram, so it like inherits all the properties, right? I said it's a parallelogram with four diagonals, so it inherits all of these properties, the rectangles do. It also has the characteristic that it has congruent diagonals. So the thing is, if you look at the parallelogram again, these diagonals are clearly not, this one's clearly longer than that one. But in a rectangle, the diagonals are the same length. And then it gets all the other properties of parallelogram, like the opposite sides are the same, and the diagonals bisect each other, and so on and so forth. That's what a rectangle is, remember. The only thing special about a rectangle is that all the angles are right angles. A rhombus is a parallelogram. and a rhombus are the same length. That's it. A square is a kind of a rhombus. It's a special rhombus. We're going to talk about it in a minute. You might be thinking, that sounds like a square. Yeah, but these angles, square and a square, all the angles are 90 degrees. Every rhombus has all the properties of a parallelogram because parallelogram. It's not good. Because it is a parallelogram. It also has its diagonals are perpendicular. That's the kind of extra thing that it gets, that a rhombus gets. Like these are right angles in here. So for a rectangle, it's all the parallelogram properties plus the diagonals are the same length. A rhombus gets all the parallelogram properties, but and the diagonals are perpendicular. They're not the same length because this is not a rectangle. A square is there's a lot of ways to say it. How would I say a rectangle with 4 congruent sides? I say there's a lot of ways. I could also say a rhombus with 4 congruent angles. I could also say it's a parallelogram with 4 congruent sides, they have 4 congruent angles, or I could say it's a regular quadrilateral. There's a million ways to say this, but basically what it means is that all the sides are the same and all the angles are the same. So the fact that I can call it a rectangle and a rhombus means it gets all the rectangle and the rhombus properties. So it gets all characteristics of a rhombus and a rectangle. Every square is also a rhombus and a rectangle. So squares are very specific. They inherit all of the characteristics of them. All right, only one more shape to talk about. That is a trapezoid, and I did not leave myself enough room here. Let's step down a little bit. Trapezoid is kind of a separate one. It's a quadrilateral with exactly one set or pair of parallel sides. So the parallelograms had two sides, two sets of sides that are parallel. This one has exactly one. You can see the ones with the arrows are the ones that are parallel. Generally, we call these, the parallel sides are called the bases, and the non-parallel sides are called the legs of the trapezoid. And in general, trapezoids don't have many properties, like how a parallelogram has opposite sides the same and all that. One thing that it does have is that these angles add up to 180 and these angles add up to 180, but that's about it. There's really not much else going on here. And I drew 3 of these because there's kind of more than one way this can look. Here, the red and the green, I don't want you to think those angles are the same. They're the same color, but they're really not the same. But like here, these are all different angles. The purple and the green one add up to 180, and the red and the blue one add up to 180, but they're all different angles. In this trapezoid, you see there's exactly one set of parallel sides, and there's 4 sides, so it must be a trapezoid. It looks like these are 90, which is fine, and then these are not, which is also fine. This is still a trapezoid as long as it satisfies this definition. We're going to call it trapezoid. And this one is a kind of a special one. Assuming, I would have to tell you this for you to be certain of it, if these two sides are the same, we call this an isosceles trapezoid. When the legs are the same length, we call it isosceles. And that has the characteristic that these angles are equal and these angles are equal. And the diagonals are the same length, kind of like a rectangle. So if it's an isosceles trapezoid, there's like some things you can say about it. If it's just a regular trapezoid, it's just kind of a trapezoid. So this is kind of, we'll probably talk about these more than the other ones, only because there's like more math you can do with them. This is like your family tree of quadrilaterals. Like I said, we're going to talk about this later. We didn't talk about the kite yet, which is fine. We're talking about that later, so I'm just going to kind of ignore it for now. Like everything below something else, like inherits properties from it, just like a regular family tree would be, like you would expect it. You would inherit traits from the people above you in the family tree. This has 4 sides, and this has 4 sides. And these are different because this has 2 sets of parallel sides, and this one only has 1. This thing goes isosceles trapezoid and it ends. But like rhombuses and rectangles are the next most specific thing after parallelograms, and then squares get all the characteristics of both of these. So these are like the most specific kind of a thing. So this little family tree sometimes helps kids like understand the concepts that are happening here. So we'll do a bunch of work with this stuff when we come to class next time. Okay, bye.